Well, that's new.
That is new.
Oh,
That was my computer.
that was your computer?
Yeah.
Huh.
It says by continuing to be in the meeting, you are consenting to be recorded.
Okay, well, I don't recall ever seeing that or hearing that voice before when we started a Zoom meeting, but here we are. It is week 8. Maybe it's an update that they slipped in there on us, and probably a lawsuit somewhere that, that they had to react to. But this isn't pre-law or anything like that. We're talking about geometry, and we've got a little bit more to finish up in this unit on polygons. Polygons, interior angle sum, exterior angle sum. Those are things that we talked about last week. They've got formulas associated with them. Properties of different kind of polygons, and that's kind of where I wanted to start today. Because if you look in your packet for Unit 6, this is kind of where we stopped on last Thursday. You'll be thankful, perhaps, to know that this section on the left talks about trapezoids. We're not going to be dealing with. Trapezoids are an interesting shape. They are a 4-sided polygon. And you can have, you see there, an isosceles trapezoid. Well, it's named that way because in some ways it's similar to an isosceles triangle. You got angles that are the same and you got some sides that are the same. Otherwise, the main thing about trapezoids is you sort of got a top and a bottom that are parallel. So it's a kind of a parallelogram, but it's got a different name because if you compare it to a parallelogram, you know, trapezoid doesn't look anything like a rectangle. You couldn't even make a rectangle out of it. Parallelogram, you could. If you stood that thing back up straight, it would look like a rectangle. So as you're going through this Unit 6, finishing up, I would make sure, if it were me, I would make sure that I keep this page handy because it's got all the properties that are listed for each of the shapes. And it's organized the way that it is for a reason. Parallelograms have 5 properties. Squares have all the properties of all of those shapes above them. Rhombus is a single. Rhombi is plural. So visually, you can probably kind of connect a parallelogram and a rectangle. You know, you take that rectangle and tilt it over. A rhombus and a square kind of are very similar in the same way. Take a square, tilt it over, you've got a rhombus. Questions about any of those properties? All right, I gotta flip this back over. So the next page in your packet gets into some surface area and volume formulas. Surface area, rectangular prisms look like boxes, right? Like a cereal box or a shoe box or Kleenex. and it says prisms or cubes. Maybe that's the small Kleenex box. Surface area is a calculation that is used all the time in packaging and in manufacturing because it's going to determine how much material is needed to wrap something. You know, if you've got a container that's shaped like a rectangle and you need to cover it completely with some, you know, a vinyl applique, for instance, for your branding, you need to know how much surface area is involved. So this formula here is kind of an odd one because what it does is it takes the area of each side of the prism twice. So how do you get the area of a sheet of paper, for instance? It's length times width. So in the diagram here, you see length times width is like the bottom of this prism. Well, because now we're talking about a three-dimensional shape, the bottom of this prism has a parallel side that's exactly the same size. And then you have the ends. Those are two the same size. Those are going to be width times the height. Okay. And then you have the front, the side facing you, and the back. That's the parallel side to the front. There's your length times the height. So you've got three different calculations to do for area. Multiply each of those by 2, and then add them all together to get the surface area. So I'm going to switch up here to my whiteboard and try to do the first one. Okay, there's my box. It's 7. Oops, I need a number, not that. 7 on that side. Let's say the bottom is 9. And the long side is 13. I'm not going to try to do those dashed lines. It's 13. Do that in a different location so it's more obvious. Try to do those dashed lines because that's just part of the box that you can't see. If it were a solid line, you would be looking through it. If it were a solid shape, you would have to be looking through it in order to see those back sides or the bottom that's on the opposite side from what you're looking at. And, you know, if you have any trouble visualizing this, then go in your kitchen, pick up a cereal box, pick up a Kleenex box and hold it up and look at it. Look at a shoe box. That's all we're talking about. If you are responsible for actually calculating how much wrapping paper you need for your Christmas gifts, you could be really technical about it and use the surface area formula. I don't know anybody that would do that, but you know, it's 2 times length times width plus 2 times length times height plus 2 times width times height. Because it's three-dimensional, right? You got length, width, and height. And you just start plugging in numbers and doing the calculation. Length times width. Let's say this is the length. And that 9 is the width. 2 times the length again, times the height. Forgot a parentheses. Plus 2 times the width times the height. Does it make sense where I got all those numbers?
Yeah.
So I get 234 for the first one. $182 for the second calculation. 63 times 2 is 126 for the last one. Then I just got to add those together. So my total surface area is 542. Doesn't, I don't know if that's inches or centimeters or what, but it's really a pretty basic calculation. Now, okay, I want to label this. Well, I was hoping they would have given us the same. I'm going to use the same shape though for the volume calculation. Volume is much easier. And the thing you have to be aware of is because this is easier, a lot of people will confuse it with surface area. If you think back to some of the two-dimensional calculations that you've had to do in the past, you know, like perimeter. Perimeter is the fence around the yard. Area is the grass inside the yard. How much grass you're going to put in there. Surface area and volume kind of work the same way. The surface area is all the outside area. The volume is what you could fill that shape up with. This volume calculation used all the time in manufacturing, and go look at your cereal box again. Look at the volume. How much is put into that. Sometimes it's by weight. Sometimes it's just by sheer volume. How much can go into it. If you're looking at let's say that same shape that I just worked on, if I want to know the volume for that same shape, it's a much easier calculation. Because volume equals LWH. You don't have to do it 3 times, you just have to do it once. And you don't have to do anything with 2 because now you're just taking 7 times 9 times 13. Volume is used for all kinds of liquids. It's used for gases. If you get a propane tank, it's got a certain volume of propane in it.
819.
That's what you got? Yep. Good. 819. It's a simple calculation. The numbers aren't going to have any relationship at all to the surface area.
Do you the answer is V equals 819?
Yep. Volume equals 819. If I'm doing both calculations on that same shape. You know, think about a swimming pool. You know, if you had if this box here represented a swimming pool, that would be how many gallons of water that you would need to put in there, for instance. Or, I'm sorry, it wouldn't be gallons, it'd be cubic feet. Because that's the other thing that you get with volume. Surface area units are squared. By that I mean square feet, square miles, square inches. I didn't spell surface area right. Well, volume units are cubed. Remember what that means?
By the third power.
To the third power, exactly. Yep, there you go. Good, thank you. So cubic feet, cubic inches, whatever the original dimensions are, and the reason. Okay, let's say that these were feet. If I got 7 feet, 7 feet times 9 feet times 13 feet. Well, foot times a foot is square feet. Square feet times another foot is cubic feet. So anytime you see a unit that's described as cubic feet or cubic inches, cubic gallons, cubic whatever, that's going to be a volume measurement. If you're talking about something that is only squared, then it's area, right? The square feet in your backyard, the square feet that you need to buy a rug to fit in your dining room, the square feet of paint that a gallon of paint can cover, all that kind of stuff. If you're buying fertilizer for your yard, it's going to tell you how many square yards that one bag of the fertilizer is expected to be able to cover. So you'd be surprised how often these kind of calculations come up. Volume probably less often than just straight area, but area is only 2 dimensions. Here we're talking about 3-dimensional calculations, not 2-dimensional. So let's see here. Let's go back up and give you guys a chance to. Let's go ahead and try the surface area here on problem number 2, and I'll pause this, give you guys a couple minutes to try that.
Is that number 2?
Yeah, for surface area. Anybody got an answer they were willing to share?
I got 542.
542. Well,
Yeah. I'm shooting it right now.
that's close to what I got. But so tell me how you set up your calculations. Maybe I got things in the wrong place.
Well, I did 2 times 7 times 13.
Okay, we're doing the second problem.
Oh, okay.
Yeah,
That's
the first
another
problem is the one that I did on the whiteboard. Yeah, sure. You know what surface area of it?
Okay.
That's what we're doing right now. We're doing the surface area of problem number 2. Surface area formula right here. Surface area would be like taking this box, wrapping it completely with nothing extra left over. That's what it means to talk about a prism. This is box. So 2 times the length times the width, 2 times the length times the height, and 2 times the width times the height. Gotta add those all, do those calculations and add those together. We're doing the second problem there right now. Belvia has joined me here in the classroom.
I think I got it.
Okay, go ahead, Jess.
Is it 580?
Yep, that's what I got.
All right.
Good. So if we did that second one just in kind of shorthand. Okay. This is what I did. 2 times 5 times 16 plus 2 times 5 times 10 plus 2 times 10 times 16. Now, I don't know if you guys did all those calculations on a calculator or not, but I actually did not. It's one of the things I love about multiplication. You can do this stuff in any order, right? So I know 2 times 5 is 10. I can multiply anything by 10 just by adding a 0. So I knew that this first calculation was going to give me 160. I got 2 times 5 again in the second calculation times 10. Oh, that's 100. I know 10 times 10 is 100. So right there, I got 160 plus 100 for the first 2 calculations. On the last one, I did the multiplication by 10 first. So I got 10 times 16, 160. 2 times 16 is 32. So add a 0, 320 for the last one. You just add them all up together. You don't have to do it that way by any means. I'm just explaining my thinking on how I would do the surface area calculation. You know, if you're not comfortable, and believe me, that's a little bit dangerous, as I discover sometimes, because trying to do this stuff in my head a lot of times is risky. So let me go turn this back on from recording. Oh, I guess I didn't pause it. I thought I had paused it. That's okay. It's good. So take a second now and do that last calculation there under volume. There's no decimals in it. That should be relatively quick and easy. Now that one, for sure, I'm going to do on the calculator because I don't know what 39 times about anything is. But volume's easier. It's just the length times the width times the height.
You want the answer?
You got it already? Yeah.
3,744.
3744. Okay, we don't know what that is, but it's cubic. Oh, it is feet, cubic feet. Okay, good. They're giving us some unit measurements there. 8 times 12 times 39. Elvia's got a question. Yeah. Doesn't matter. Nope. You only got 3 sides for 3-dimensional. You can call the length. Length is typically the longest side of a shape, but if it's a cube, they're all going to be the same length, so it doesn't matter. And then what you decide which ones you want to call the width and the height. But because it's just a straight multiplication of the 3 numbers, it doesn't matter which ones you call which. It's just length times width times height. And you're done. (3,744 cubic feet). Now, this may not affect any of us, but you know, let's say at some point you decide to move to San Francisco and go to work in one of those big shipyards out there where they're bringing in these giant cargo containers from China and Japan and every place else, you know, the gigantic ships loaded full of them. Those are all going to be measured. The volumes of those containers is all going to be measured just like this. Probably cubic feet, some of them cubic meters, maybe, if it comes from certain parts of the world. If you see 18-wheelers rolling down the road with those cargo containers on the back, somewhere on it's going to be labeled how much the volume is. So very common calculation. Question, anybody? And see, I don't even have that page in my teacher's handout. I don't know where it comes from, but what you do need to know it for this last test. If you've already taken the Unit 6 test, like I said before, it is the last of the unit tests. There is no unit test for circles. We do need to know a couple of the formulas in the unit on circles. Anybody know anything about circles? Okay, we're going to do that on Thursday. And then start to look at things that are going to go into the final. I'll have those other couple of homework assignments posted today. They're not large points, so don't worry about that. Again, it is to help you identify the stuff that you're likely to see on the final. 10 questions on the final. Yep. It's only 10% of your grade. You got 6 unit tests. That's 80% of your grade. That's plenty of information to determine whether or not you've learned it. The final is just icing on the cake. It's, you know, if you're borderline between a B and a C or a B and an A, the final, a good grade on the final will put you over. So the study guide's part of your packet. Anybody remember that formula for the sum of the interior angles of a polygon? S equals n minus 2 times 180.
Yeah, I was getting there. Dang it.
Yeah, n being the number of sides, right? Here, and I am going to pause it this time. The rest of that page talks about exterior angles of polygons. Question number 9 is a giveaway for you because it asks you what is the sum of the exterior angles of any polygon. Any polygon. It's not a trick question because it's the same number for every polygon. That's why it says for any polygon. How many degrees do our exterior angles always total, no matter how many sides a shape has?
$360, right?
360. Yes, thank you, Jonathan. No matter how many sides a polygon has, the exterior angles always total 360. So once you know the answer to number 9, the rest of these are easy. Number 10 says what are the measures of each exterior angle of a regular nonagon? Well, nonagon is 9-sided. It's a regular nonagon, so they're all going to be the same. So 360 divided by 9, 40 degrees, every one of them. 11 and 12 kind of turn the formula around a little bit, but it's still the same basic thing. You got 360 total degrees. And then you have to figure out how many sides are involved. It's just the flip version of problem number 10 in essence. 13, kind of similar to the problem number 7, where we had to add all these up to get the interior angle information totals so that we could find X. Here we know already that our total is going to be 360. So it's the same basic setup. You're going to add all those things together to total 360 and then solve for X. So how many X's do we have here? 11, 4 is 15, 6 more is 21X, and 9 more. There's 30X there altogether. And then you just add up the rest of the numbers, make your equation equal to 60, and then it's solvable. So I'm going to pause this again, and Jonathan's computer is going to tell us that the recording is paused. The next section gets into parallelograms. This is where you need to have that graphic organizer right next to you. Because to understand what we have with parallelograms, where's my graphic at? No, not the trapezoids. These are the properties that you're going to need to remember, and you're going to need to work with them in order to solve these problems. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles supplementary, diagonals bisect each other. So they give you the parallelogram and they give you a bunch of numbers. They give you some side lengths. EB is 16, that's that left-hand side. ED is 25, so that's the bottom. BF is 11. EC is 34. Okay, well, that's just the lengths. No angle measures yet. So properties that are going to come into play on the side lengths or these diagonal lengths opposite sides are parallel. That doesn't do anything for us. Doesn't tell us, it doesn't help us figure out any measurements, but opposite sides are congruent does help us. So if I know that EB is 16, then I also know that DC or CD is also 16. Opposite sides are congruent. So that's where you fill that in over here in this little table. ED is 25. So, okay, it's the opposite side for ED now is BC. Those are congruent because the properties of parallelograms tells me so. So BC is also going to be 25. Well, there's another blank to get filled in. So BF is 11. FD is probably something we're going to need to figure out. Now EC goes all the way across. That's 34. So do we have any properties that deal with diagonals? Well, lo and behold, we sure do. Diagonals bisect each other. They cut each other in half. So if BF is 11, how much is FD? They don't even ask us for that.
11.
How much is BD?
21.
Almost 22. 22, yep. Because this diagonal, they bisect each other. So if BF is 11, FD also has to be 11, so BD has to be 22. The opposite of that here is what you're looking at to figure out the parts of EC. EC is 34. So how much is FC? It's going to be half of that, 17. I really haven't done any calculations here. All I've done is to try to use the properties. And the angles are going to work exactly the same way. The measure of angle BED, this one is 55. So I'm going to put a semicircle around this one and label it as 55 degrees. And because I know my properties, I already know that opposite angles are congruent. So if BED is 55 degrees, then BCD is also 55 degrees. CDB, that one's 67. BCE is 24. You got to use your properties now. Opposite angles are congruent. Consecutive angles are supplementary. And what else do you have to work with here since these are parallelograms? What do those diagonals, how do they function inside this any parallelogram?
Shows how many triangles can fit in it.
Triangles? Yep, for sure. What about angle relationships? What do they create? We're talking about parallel lines being cut by transversals. Those diagonals act like transversals. So don't we also have alternate interior, consecutive interior, all those potential kind of relationships inside this shape that's got parallel, that's bounded by parallel lines and cut by these transversals? Heck yeah. So like CDB here, it's going to be the same as EBD because that's alternate interior angle. And there's where you fill that in. So the angles part's a little bit different because not only do you have to remember these two pieces, opposite angles are congruent, consecutive angles are supplementary. Supplementary is 180, remember. But you also have to remember all of the stuff about parallel lines and transversals, creating those alternate interior or perhaps even consecutive interior angles. Alternate interior angles are congruent. Consecutive interior are going to be supplementary. But if you just ignore for a second that BE and CD are in that shape, just put them out of your mind. Now you're looking at parallel lines cut by two transversals. Questions on any of that? 15, 16, going to be doing the same thing here. What are the properties? Okay, these here, K and M, angles. Opposite angles are congruent. Okay, that's an easy equation to set up then. K is going to equal M. So I'm going to take this expression 8x plus 17, make it equal to 12x minus 39. But then I got to find angle N. How do I do that? It's not that difficult. But you got to figure out what X is first. Back to the whiteboard. Parallelogram. I got this angle. I got this angle. One of them is 8x plus 17. The other is 12x minus 39. Property tells me that they're congruent, so I can make them equal to each other and solve for x. 12x minus 39 equals 8x plus 17. I'm going to subtract 8x from both sides, so my x terms are positive. Now I'm going to add 39. 56. X equals 14. Okay. So the problem's asking me how much this angle here is. It's angle N. How do I figure that out now that I know what X is? Okay, well, we use the one property of parallelograms. We use the one property of parallelograms. Opposite angles are congruent. Okay, and now we need to use the second property involving angles. Consecutive angles are supplementary. Consecutive means you start in any corner and you just take your finger and go around the parallelogram and back to your beginning point. The next angle you see is consecutive. Then you go to the next one, that's consecutive. Next one, consecutive. 4 angles. Consecutive angles are supplementary. So supplementary, consecutive angles, those two are going to be supplementary. Supplementary means equal 180. These two are also going to be supplementary. I already know that 12x minus 39 and 8x plus 17 give me the same angle measurement. So what is that? 8x plus 17, 8 times 14. Where did 14 come from? That's how much x is. So 8 times 14. 112. So 112 plus 17. So that angle is 129, and so is the other one across the way. So N, what's N going to equal? 180 minus 129. Because that's what the property tells me. Consecutive angles are supplementary. So together, they're going to have to equal 180. So 180 minus 130 would be 51. So this is 51. N equals 51. Multi-step problem, you got to figure out what X is first. All I did was use the properties for angles in a parallelogram. Anybody have a question about how I did that? '16 is going to be similar, but now we're using that same sort of property. But are U and T going to be equal to each other in number 16? How are you going to set that one up? Are they congruent to each other?
No.
No. They don't look like they're congruent, so that's your first clue. And the property tells us, because they're consecutive, that they're going to total 180. So that's a different equation set up to find X for number 16. You're going to have to add these two together. These together are going to equal 180. That's how you're going to find X on that one. And then another multi-step problem, because now it's asking you to find what R is. And you got some options. You can figure out what T is. The other property says T and R are going to be congruent because they're opposite. Or you can do R plus U equals 180, like we just did on the problem number 15, because R and U are consecutive. So you always have options. So I think the last one we have time to talk about today is number 17, but I would encourage you guys to keep going through the problems in this handout and checking with me if you've got questions or you want to get some feedback on whether you're doing something correctly. So here we got a parallelogram ABCD. If ED is 7x minus 13, well, okay. Wow, ED is 7x minus 13. So that's this half of this diagonal. How do I know it's half? Well, it's because the diagonals bisect each other. That's one of the other properties. BD is 16x minus 38. Find BD. What are you going to do to set that one up? Well, I mentioned it already. ED is half of BD because diagonals bisect each other according to the properties for parallelograms. Diagonals bisect each other. So if I take this one, ED, and multiply that times 2, that should equal BD, wouldn't it? Because if ED is 7x minus 13, BE also has to be 7x minus 13. Otherwise, it's not half. Once you figure out what x is, plug it back into this expression, BD equals 16x minus 38, and you'll have your answer for BD. And pretty much puts us out of time for today. Anybody got questions before we sign off?
You look
All
up
right.
my for this class.
What's that?
I was trying to see what my grade is with this class before the next 2 tests are done.
You know how to get into synergy? Check your grade there.
No, I don't.
Okay.
Build me in on that one.
Okay. Should be able to see it in Google Classroom. I can. You've not done the parent view thing for synergy?
No.
Okay. If you can't find it in Google Classroom, let me know and I'll text it to you.
I don't even know how to look for it at all.
In Google Classroom, it should be listed under your coursework somewhere.
Classwork?
Classwork, coursework, yeah.
No, it's not. It's not in here.
Well, it's set up so everybody can see their grade. So I don't know where you have to go look for it then. Just gonna have to poke around in there. If you can't find it, let me know. All right, I'm gonna let you guys go. Thanks for being here today.
See you in a minute.
All right, talk to you later.